This video will look at how we deal with significant figures when we are adding or subtracting. A later video will look at dealing with significant figures in multiplication and division. First, a reminder, we're concerned with the number of significant figures in measured quantities, such as lengths, diameters, volumes, voltages, currents, things like that. When we are measuring these things, there's a limit to how precisely we can determine them, usually depending on whatever we're using to measure them. And the reason we learn to use significant figures is so that we can tell other people the limits of the precision. And there are accepted rules for doing that, and that's the purpose of these videos. Suppose we measure a piece of metal, and using our best measuring skills, we find that its length is 3.45 centimeters. We're absolutely sure that the measurement is between 3 and 4 centimeters because one end is down there and the other one's between the 3 and the 4. We're also absolutely sure that the measurement is between 3.4 and 3.5 because I can see that end right in there. What I'm not sure about is the nearest hundredth, but I think it's about 3.45 is about the best I can do, because when I look at where this lines up, it's just about halfway between the 3.4 and the 3.5. Now, someone else might look at that and think that maybe it was 3.44 or 3.46, but all of us would agree about the 3.4 part. We say that that 5 that we have here is the least significant digit, and that's one where there's a little bit of uncertainty, where the uncertainty first shows up. Now suppose we measure another piece of metal, but this one we measure with a more precise instrument. There's a device called a micrometer that we could use. This is what a micrometer looks like. And this particular micrometer would let us measure the length of an object to the nearest thousandth of a centimeter. Using the micrometer, we determine that this second piece of metal is 2.321 centimeters in length. So we're able to measure that it's that much. This first one was 3.45 centimeters. The second one is 2.321 centimeters. Now, if we put those two objects end to end, how long will the new length be? This is just an addition problem, but we're going to be thinking about the significant figures. To understand how we deal with this, it helps to set this up as a vertical addition problem, like this. And I'm going to put a red box around the least significant digit in each number. That's where the uncertainty in the measurement first starts to show up. So in this number, the uncertainty first shows up in this digit. In this one, it first shows up in this digit. Now, I add these things as I usually would, and I'd get 177 and a 5 there. So that's the way I'd usually add it. Now I consider where the uncertainty shows up. This digit I know is uncertain. In this column that I add, because this digit is somewhat uncertain, it doesn't matter what I add to it, the result will still be somewhat uncertain, and so the uncertainty first shows up here. Now, if this digit is uncertain, this one is less than uncertain, and so I don't even keep this. I round the number. I would use this for rounding purposes, although there's no need to round here, but I round it to where the uncertainty first shows up. And when I do this addition, the result will be 5.77. I don't keep that figure. The uncertainty first shows up in the hundreds place here, and so that's as far as I can keep it. And this example demonstrates something that will happen with all of our addition and subtraction problems. we won't keep numbers beyond the first column that has uncertainty. And we call that a place in math classes. It may be, in this case, it was the hundredths place. Sometimes it'll be the tenths place. Sometimes it'll be the hundreds place. So that's just may be the way it works out. We may use the numbers beyond that place for rounding purposes, but we won't keep them for anything other than that. Let's look at another math problem here. Add these two together, and we'll see what we get here. When I add these two before considering the significant figures, I would get 1683.793. Now, I'll start considering the digits that are least significant. In the top number, the least significant digit, the one where the uncertainty first shows up, is the 3 there. In the bottom number, it's also a 3, but it's out here in the thousandths place. In the result, there will be uncertainty in this one, but there will also be uncertainty in this digit as well. And if the uncertainty first shows up in that 7 there, there's no point in keeping anything beyond that, although in this case I will use the fact that I've got a 7, 9 here to round this up to an 8. And so my result would be 1683.8, and that's as much as I can keep. Let's look at a subtraction now. We'll subtract 8.35 from 13.1. I'll set this up as a vertical subtraction problem. And again, I emphasize the least significant digit as part of my solution here. So when I set this up and do the subtraction, I would get 4.75. Now I'll consider where my uncertainty first shows up. In this top number here, the least significant figure is this one right here. In the bottom number, the least significant figure is here. When I perform the subtraction, any number that came about as a result of some uncertain number is itself uncertain. So in the subtraction, the uncertainty first shows up here in that 7. And because that's uncertain, I don't keep this number beyond it, the 5, although I do use it for rounding purposes, and I would round the subtraction to 4.8. And so there's my result. It's got just 2 significant figures. Now, I started with 2 numbers, each of which had 3 significant figures, but my result has only 2 significant figures. That's common with subtraction when you start considering significant figures. For a more extreme example of that, take a look at this subtraction here. When I perform this subtraction, I get 0.73. Now, I can't keep that many significant figures because in the top number, the least significant figure is the 10th, or the 10th place. That means in the result, it will have to stay in the 10th place. And so I can't consider anything beyond that other than for rounding purposes. So the result of this ends up just being 0.7. I went from a number that had 4 significant figures, subtracted one that had 5 significant figures, and I end up with a result which has only 1 significant figure. So that's quite a reduction in the number of significant figures, but typical of subtraction. To finish this video, I'm going to show you a series of addition and subtraction problems and just talk about where the result will have its last significant figure. You might pause the playback here to see if you can figure out each one on its own. So pause it here if you're interested in doing that. I'm going to talk through the solutions of these. This first problem here, the uncertainty in this digit, the least, or this number, the least significant digit, is in the hundredths place. In this one it's in the thousandths place, but if I'm reading left to right, it first shows up in this one, and so when I add these two numbers together, I won't keep anything beyond the hundredths place. These two numbers here, this is only accurate to the nearest ones digit. This one is good to the nearest thousandth of a number, of a digit, to the thousandths place, but I'll have to round the result just to the nearest ones digit, so it'll show up in that digit. It'll be, I can do it in my head, it's 541, and that's it. These three numbers here, each one is accurate to the nearest tenth, and so I'll be able to keep the result here to the nearest tenth. I look at this subtraction problem here. Again, I've got a number that's only good to the nearest one. This is good to the nearest hundredth here, but this one's only good to the nearest one, so I'll have to round the result to the nearest one. No decimal point at all. Look at this. This one is good to the nearest 10,000th, but this one's only good to the nearest hundredth, and so I'll only have two numbers after the decimal point in the result of this subtraction here, so to the nearest hundredth. Now, this number here, I've only got two significant figures in this thing. It's only good to the nearest 10, and so when I add this number to it, that's only going to be good to the nearest 10, the result will be. Well, when I round this to the nearest 10, I get 10. The result of this addition will be just 560. I can do that in my head. This last problem down here, I've got 55,000. That's only precise to the nearest thousand that 55,000 is. I can't count these as significant figures. I'm subtracting 76.2 from it. I can kind of do it in my head. If I do that subtraction, I'd end up with 54,900 and some, but I can only round that to the nearest thousand, and so the result of this subtraction is going to be 55,000, because none of these are significant figures. I hope this video helps you understand a bit about how significant figures work with addition and subtraction. If you have any questions, feel free to ask me in class. If you're one of my students, you might try watching the video again. There are many other videos on significant figures that you can watch as well.